I chose a few ones to do in class here today. So let me start with this one. And I'm going to do this for your purposes, Delano, because you there's something that you didn't understand yesterday. So um, for this one, of course, these are our x values and these are our y values. So I'm going to integrate, um, and then I'm going to do this. And what we're going to do is work our parentheses first. All right. So we're going to do dx by dy. So we're going to do our outer function is going to be dy. So we're going to go from 0 to 3. And inside we're going to go from what, -5 to 4. Okay. And our function, I'm just going to put in our function. Our function there. And this is dx. Okay? And then everything out here is dy. So what we're going to do, we're going to work our parentheses first, which is the integral of this from -5 to 4. All right?
Instead of focusing on the inner function,
Pardon me?
instead of focusing on the inner function, on the inner,
the inner integral.
Yeah, the inner integral.
Right. So, in other words, this is what we're concentrating on, and we're going to leave all of everything outside alone while we deal with inside.
So Delano, in a sense, what I don't know is going to integrate with respect to x, the x form, the x.
Yeah, x, the dx.
All right. Or another way of putting it is that I am evaluating my parentheses first.
Yeah.
Okay?
So that's going to be 2x squared.
Well, hold on. Before we get there, we're going to put in back our 0 to 3. Right? And then we're just going to integrate what's inside here now. In other words, that's what we're dealing with. All right? So let's integrate it with respect to x.
That become 2x squared over 2.
Okay,
Minus 4y cubed.
Over 2, yeah. Okay, minus.
Minus 4y cubed.
Not quite. Try that again.
So you say you're doing in respect to a, saying treat the y as constant.
Right. So if all of that is constant,
would that be 4y cubed or?
No.
Oh, 4xy cubed.
There you go.
Yes, yeah, that is doing with respect to x, so yeah, that being x.
And of course, as always, I forgot my to do this first. So let me just okay.
Somebody put the mic, this is acting now.
Okay. All right, let's leave that. And we're integrating this from what? I didn't hear what you said, Mr. Lodge.
You were saying somebody's background had a clicking sound.
Oh,
-5 and 4, sir.
okay. Okay. So what we do next?
dy.
Oh, no, there's something we forgot.
dy.
There you go.
And
So
that.
see, we still have our outer function. We're still working with our inner function. All right. So what does I'm still gonna put back my 0, 3. Okay. And let's evaluate this.
That is
I'm going to put in some parentheses because I always like to put in parentheses because it keeps my minuses in check. All right.
So that becomes x squared.
Well, yeah, the 2's cancel. So it's going to actually be, well, let me just cut and paste. All right, x squared. Continue.
Minus 4xy cubed.
All right. Let me do what you said. Yeah. Yeah. Go, continue.
You're going to put back that you're going to put back the 4 the 4 to the 15.
Right, hold on, let me just do this. I'm doing it this way. Copy, paste. All right.
So you're doing now, you're plugging in
We're
the
evaluating this from -5 to 4. So it's really this evaluated at 4 minus this evaluated at 5. So I am going to put in a 4 here.
So all right. So we couldn't what so you're always putting so
Okay, remember, so it's just x, it's just the x's are changing. And I'm going to put a little parentheses here, so okay.
So sir, why not the 5 first?
Because the upper limit is 4. It's the upper limit minus the lower limit.
Okay, cool.
Okay. So I'm going to put in a parenthesis here, and this is -5. And I'm going to put in a parenthesis here, and this is -5. Come. Oh.
Wrong part.
Come, you're not giving me, okay. Okay. All right. Oops. What did I forget?
The dy dx on the outside.
No, just what? Just dy.
Dy, yes.
Okay. So let's work out the parentheses now.
So it is equal to 4 4s.
16 minus 16y cubed. Yeah? That's what this part of it is. Yeah.
Hold on. How did you get the 4 square again?
The 4 squared, I substituted this 4 for this x.
Oh, okay. And the 2 cancel it.
Let me do this. I'm crossing out my 2's. All right? Because the 2's cancel.
Okay, I just didn't realize I get that now.
Okay.
And the -5 would have represented the
This -5 represents this 5 here. Because it's this equation evaluated at this number here minus
the same equation
evaluated at that number there.
Oh, okay.
All right.
All right. So -5, yeah. So that.
Okay, 0, 3. And then now, this is 16 minus 16y cubed, right?
Yeah, so that leave only y cube.
16 minus 16
Oh, 16y cube, right.
y cubed. All right. Negative 5 squared is a positive 25. So that's just minus 25. Agreed?
Bracket it's
Negative
oh,
5
yeah.
squared. No, I'm removing
Oh
all
yeah, it
parentheses.
become positive, right? So the
Yeah.
negative out there can stay.
All right. Negative 4 times 5 is 20. Sorry, 4 times 5 is minus 20. Minus 20 times this negative gives us a positive 20. A positive 20 times this minus gives us a negative 20y cubed. Agreed? All right. Negative 20y cubed.
Sir, you're gonna confuse the thing. Why not put back the bracket just to prevent the confusion?
All right. That is just creating one more step, but I can do that.
All right, make it safe. Nobody.
No, I can do that. Let's do that. So this is.
That would have been plus 20.
Wait. First of all, let us
bracket that.
Bracket it first.
And put back the plus 20.
All right. So this is a positive 25, and this is negative 4 times negative 5 is a positive 20. And that's it. Oh, no, that's not it.
dy.
The dy.
Okay. So let's continue. 0, 3. Okay, now 16 minus 25. I'm removing parentheses now. Or you want me to do another step in just
No, sir. That's good.
Huh?
That's good.
All right.
16 minus 25. Negative 9.
Negative 9, right? Negative 16y minus, because this minus is going to change that into a minus.
Minus
So,
21. That's minus 36. 36y cube.
So that's 63, not 36.
Oh, thank you. I'm dyslexic, you know. All right.
Y.
Oh, yes. Thank you. Thank you. dy.
Sir, when your homework due again? When your assignment due again?
Next week, I think it's Wednesday.
Wednesday?
I think I put it to Wednesday, yeah.
Okay.
I'm trying to put a parentheses around it, but sure, it's not allowing me to.
So the next step would include us substituting 0 and 3 into that integral.
Yeah, we find the
integral.
integral
We have to integrate it first.
Can't remember so the integral sign.
So we are integrated first and then substitute.
There you
So
go.
that would be negative 9y minus 36 y to the 4th.
No. Yeah. Minus 36 y to the 4th.
4th over 4.
Yeah. Y to the 4, and this is all over 4.
Right.
And of course, you know what I forgot to do, as usual.
dy.
No, you don't put your dy here. You integrate it.
The upper and lower limit.
Yeah. And this is going from
0 and 3.
0 to 3.
From 0 to 3. All right. So let's do that now. Let's put it in and then clean house. Again, I'm going to put in my brackets so that my negative signs don't get all messed up. So I'm going to put in a 3 for y here. Let me put in another parentheses just to make sure. All right, so this is going to be -9. -9 times 3. Yeah?
Yes, sir.
Minus. Oh, 4 into 36 goes. Hello?
For, I think it's 8 times. 4, no, 8. I think. Don't quote me on that.
What you say? No, it's
I
9.
think it's 9. I don't know about you.
It's 9.
Don't quote me on that.
minus 9. And this is going to be times 3 to the 4th power. Yeah? 3 and all of this must be raised to the 4th power.
So 3 times 3, that's a 9. 9 times 3, that's a 36.
That's to the 4th power. Okay. Yeah?
Yeah, and then the next one will be -0.
And it's going to be minus. Okay. When I put 0 in here, that goes. When I put 0 in here, that goes. So it's just -0. Everybody understands why it's -0? Let me turn on the chat and see if anybody is responding. No? Okay. So so let's continue.
That is equal to
9 times 3, that's -27. Minus 3 to the 4 is 3 is 9, 9
36 times 9.
No. 3
3 trees.
9 3 is 27.
Oh,
27
27
times
right.
3. 27 times 3.
Sir, 3 threes.
729. Huh?
3 threes and 9, and then three nines.
No. It's 3 raised to the 4th power.
Oh. For some reason, I think about 3.
3 is 9, 9 is 27, 27. Okay.
That's 81 times 9.
That's 81 times 9, which is 729.
Hello? Hello?
Hello?
Yes, sir. Can you point out the 0 came in?
Him substitute the 0 in the next function. Just like how the up the top.
The 0 into the y. So -9 times 0.
Oh. Yeah. Never mind.
And 36, 0 raised to the 4th power. Times 36 divided by 4. All of that gives you 0.
Yeah, I wasn't paying attention during that time.
You see why you should pay attention, Delana?
I was distracted.
All right? And that's the answer.
So it's easy, sir.
Pardon me?
So you make it look easy.
Well, all right. Let's go to this one, because I particularly like this one.
Sir.
Yeah?
Anything you like, anything you like, always not good enough.
All right. So who's going to walk me through this one?
Delano.
Can you scroll up for me, sir? Lydia?
Me, I don't know. I
I
remember.
don't appreciate you volunteering me.
Huh?
I don't appreciate you volunteering me.
You're normally the voice of the class.
Alright. I'm going to set this up the same way how I set up the other one.
So does that mean I speak for the class when I say you should assist, sir? That I'm the voice of the class.
No, the voice of the class. You're the man of the class. You know, the man leads.
Alright. How I'm going to do this one? I'm going to do 0 to 1. Which means that my y is going to be my outside function. My y, why am I always choosing y as my outside function? Anyway.
Why you do it like that?
Oh, okay, sir, let me see back something up the top. So your y is your outside function. In this case,
you can do it anyway.
Hold on there. So in this case, okay. So your x, hold on.
No,
so
in this one, x was the inside function.
Oh, so sir, that means that
that's when you work out -5 and 4 first.
And that is not the only thing that you need to take in consideration. That is why dx is integrated before dy also.
Yeah, because y and the outside function.
Right. I never did realize that, you know.
And so in the other one, you must go
you want me to work this out? You want me to work this out the other way and show you that you get the same answer?
Sir, I think you did that the last time. That's
okay,
good.
All right. Okay.
Switch it around.
No, sir, what I'm saying is that what I realize is that dependent on what integral you put on the inside, it determines the order in which you integrate. So
here you go.
So in this case, you're using y at the front, so we have to find dy first.
Yes.
No. I'm putting dy first.
Oh, yeah.
So it's going to be the last thing I do.
Yes, so that makes
right. Yeah. So if you put dy where x is known, you have to put dy first, then dx.
Yes.
That's what she was trying to allude to.
Yeah, that is what I was trying to.
All right. So this is my x values. So this is going to be dx. And then I'm going to have dy on the outside. Okay? And this is what we are integrating first. Now, it's going to be a little tricky. You know that we can separate it, each term by itself. We're doing dx first. So all of this is just a constant. Sorry, all of this. There's no x involved here, so it's just a constant. This is going to be our troublesome term. You agree?
What is going to be the constant term, sir?
This term here, sine pi y. Because remember, y is going to be a constant.
Okay.
So that
means that means that also the y squared will remain a constant term.
There you go. All right. No, because I know that there's something coming, I'm going to do something. Well, no, let me do it step by step. And we'll all right. So what we have there is going to be equal to the integral from 0 to 1. 0 to 1. Okay, let's integrate now. We're integrating x first.
So that becomes x cubed over 3.
Yeah, okay. 3. I'm going to write it this way because I know what is coming.
We don't know it, sir.
x cubed, right?
Right.
All right. The next term.
Plus y squared.
Think again.
Oh, because it's a 1 would be in front of it.
There you go. All right. Plus, okay, we're going to integrate this now. And to integrate this, enter. Let's enter here. Let's create some space. Insert equation. I am going to remember how to, you remember how to integrate cosine of a multiple? We're going to say u is equal to.
Oh, the use substitution.
Where's my pi? Can't find my pi.
Yep, go back, sir. Go back. Go to the end, the next end. Continue to the end,
Oh,
right?
Yeah. So we're going to say u is equal to pi x, and du is equal to
What is the integral of cos, Delano?
is equal to pi dx. Yes?
Pi dx is the integral of what? Is it different?
No. U is pi x. So integrating this, remember there is a imaginary 1 there. You subtract 1 from it, you get 0. So the x goes. You multiply the 1 by the pi. So it becomes pi dx.
And technically dx becomes
And oh, there you go. Oh, you got it. Where's my equivalent sign? All right, equivalent to saying dx is equal to 1 over pi. 1 over pi
du.
Yeah?
Right.
So this integral here can be rewritten as integral, I'm just going to work it that way. The integral of, oh gosh, why are you doing that to me? Cosine u du. Oops, and then we put our 1 over pi in front. Isn't that how we used to do it?
Sorry, I can't type. Oh, pi. See pi there.
How you type pi? Pi?
No, I think I did something else there I could put.
Oh, okay. And what is this equal to?
What's the cost of, I don't know we never did a class. No, really, I wasn't at the class when you were integrating the cosine and all them something.
Okay. So it's either sine or minus sine. Which one is it?
I think it's minus sine.
Yeah, go ahead.
Just rereading the chat there, Delano is saying that we're in a 40-minute session and it ends in the next few minutes. So just a heads up.
Oh
yeah, it ends in 6 minutes, 33 seconds.
Okay, all right. So who can remember what the integral of cosine is? Let me just try to finish this quickly.
So you don't have to rush it up. I'm going to start a new one like when I'm gonna do.
Oh, okay, all right.
Yeah.
Sine.
As we're alluding to that, so could you clarify the 1/3 thingy?
The 1/3. Where's the 1/3?
Technically, is 3 over. Is remember when x to x squared is same thing like him said x to the cube over 3.
Oh, that, yeah.
So you put the 1/3, you're confusing.
All right. Let me. All right. Is that right?
It's not confused. I just didn't see it.
We can do it that way. We're just going to have to move it off later because, as I said, I know what's coming. Where was I? The integral of sine, the derivative of sine is cosine. The derivative of cosine is negative sine. So sine is cosine, right? So it's just sine u. So that is what the integral is. So we're going to put in our copy, paste. And I'm going to change back my u to my where's my u? Pi, right. At least let me use it from here because I want to capture the bracket. Yeah. Copy. Okay.
All right. So what's that? 1/5.
So that's what I did here. So for the next term, we have one more term left. And how do we integrate this? Any ideas?
So
Yeah.
when you finish, I can also explain the middle part there with the 1/5. Then
Okay. Nobody not telling me how to integrate this one.
Lydia,
It's okay, I integrated it.
I hear my name calling. I just
Okay. So I was asking you to tell him how to integrate
which one again? Which one?
I think it was du.
This one, to integrate that.
All right, you write it yet? So we're going to use u being pi y.
No. Why is it going to be pi y? We're integrating with respect to x.
Oh, so we're going to use x.
Pi xy.
No, x. We're going to use x sign. That's what you want to use, sir?
It's going to be x sine pi y. Because remember, all of this is a constant. Remember, I told you it's a constant.
Oh, and then add the x to it.
Oh. How am I going to do this? Okay. I don't know how to do this.
What you're doing, sir?
The mistake that I always make.
So why you never just integrate it in a parts then, sir?
No. The mistake I'm talking about is this. And I want to put this in there, but it's not copying properly. It won't allow me to, all right. Go. And let me see if it will take this now. Yeah. Go. Okay. Oops. Undo. I want it here. No, I want it here. Yeah. So there we go. And we're integrating this to what are our limits here?
-2, -1.
Yeah. -2, -1. And what am I forgetting?
dy dx. dx, dy.
Thank you. All right. Now, let's evaluate. No, we're not evaluating yet. We're just putting in our -1s for x's and we're putting in our negative 2, I mean minusing or negative 2s. 0 to 1. I think we're about to end, right?
Yeah, less than 1 minute.
Okay. So negative 1 here, negative 1 cubed is still negative 1 over 3. Yes?
Right.
I should put my brackets. Oh. So this is negative 1 over 3.
Mm-hmm.
What's the next term?
Plus negative plus bracket negative y square.
I like to put in my